Yes, students, in this video, we are going to study furthermore antenna parameters like average power density of isotropic antenna, radiation intensity, gain, and directivity, and the relationship between directivity and radiation intensity.
Uh, Today, we will discuss regarding what is the average power radiated by an isotropic, and the previous class we have already discussed what is meant by an isotropic antenna and directional antenna. Isotropic antenna means it is not physically available, it is just a hypothetical lossless antenna, which is taken as a reference for expressing all the properties of antenna, which radiates equally in all direction. But all our practical antennas are directional antennas, which radiates only in particular direction. Okay, now we'll see, we'll derive the expression for what is the average power radiated by an isotropic antenna. Okay, so let us consider here. Let us consider an isotropic antenna which radiates, it radiates equally in all directions. So it radiates equally in all directions. So this is an isotropic antenna. In any direction, it radiates equally in all directions. Okay. Now consider an isotropic antenna is placed at the center of the sphere. Okay. So then all the power will be radiated by the radiator on a radiator and passes over the surface of the sphere. What is the surface area of the sphere? The surface area of the sphere is 4 pi r. Surface area of the sphere is. Then at any point, you take any point. Okay, you take any point. Let us take this is point P. At any point on the surface, okay, the Poynting vector P, the Poynting vector P gives the power radiated per unit area. Use the power radiated per unit area in any direction. But here the power is radiating in radial direction, R direction. Here all the power is radiating in radial direction, means R direction. So now the total power radiated, the total power radiated, the total power radiated is equal to double integral of ds. Okay, already you know what is the formula of the ds. ds is equal to r square sine theta into d theta d phi. So this is the formula for ds. Okay. So since all the power is radiating in the radial direction, call it as, so this is total power is equal to beta ds. Since all the power is radiated in radial direction, it is called as PR into of P. Since all the power is radiating in a radial direction, call it as P. Okay. So you can assume that PR is equal to P average power, since the radial component is equal to the average power. Therefore, total P radiated is equal to P average into double integral of ds. Okay, so with the ds value is this one. Okay, so that is P average into double integral of the value of phi is from 0 to pi, the value of theta is from 0 to pi, and the range of ds is r square sine theta d theta d phi. Okay, so if we do here sine theta, here no r component is there, therefore P radiated is equal to r square into P average, that is this P average is there, no R square component is there. So sine theta, what is the integration of sine theta? Cos theta. If you apply the limit 0 to 2 pi, you will get 2. Okay, so that is integral into 2. Okay, so we will get P average into 4 pi. Okay, so from this, what is the final expression for P average? P average is equal to P radiated by 4 pi R square. So this is very, very important. So average power radiated by an average power radiated by an isotropic antenna, P average is equal to P radiated by 4 pi R square. This is the this is taken as reference. This is taken as reference. The total average power radiated by any isotropic antenna is equal to P average is equal to P radiated by 4 pi R square. Okay. So this is considered as average power radiated by any isotropic antenna. Okay. Now let us today we'll discuss regarding another parameter, radiation intensity. Another parameter, that is radiation intensity. Radiation intensity. So the radiation intensity is represented with U of theta. The representation is U of theta comma phi. Radiation intensity is defined as power per unit solid. Radiation intensity is defined as the definition of radiation intensity is power per unit solid angle. Already we have discussed what is meant by solid angle and what is meant by plane angle. Okay. So the other definition of the radiation intensity is the radiation intensity of an antenna is the radial component of average power density, radial component of average power density multiplied by square of the radius at which the radiation intensity is measured. That is the other definition of radiation. The radiation intensity of an antenna is the radial component of average power density multiplied by square of radius at which the radiation intensity is measured. Means the other formula is U of theta comma phi is equal to R square into PD of theta comma phi. So it is square of radius of radial power density. So another formula. This is another formula for radiation. One formula is power per unit solid angle is called as radiation intensity. Another formula for is it is R square into PD of theta comma. Okay. So now let us bring the relationship between average radiation intensity and general radiation intensity. Okay, so we know that the total power radiated, the formula for the total power irradiation is equal to the formula PD of theta comma phi into ds. Okay, so what is the formula for the ds? Already we know that the formula for the ds is r square sine theta into d theta into d phi. Okay, so I apply the limits. Phi is from 0 to pi. Theta is from 0 to pi. So it is PD of theta comma phi r square sine theta d theta d phi. Okay. So this is the expression. Okay. So, but what is the formula? You know that U of theta comma phi. What is the other formula for it is r square into PD of theta comma phi. So, in the place of this one, I can simply replace with U of theta comma. Therefore, P radiated is equal to that is, so what we call this sine theta into t theta into t omega, it is nothing but so double integral of U of theta comma phi into d sigma. Okay, so this is nothing but d sigma. This is d sigma. This entire sine theta into t theta into t phi is equal to d sigma. Therefore, next. Here, T radiated. We can consider it as U of theta comma phi is equal to as U average. Therefore, that is U average to double integral of phi range is from 0 to 2 pi. Theta range is from 0 to pi. That is sine theta into d theta into d phi. Okay. So that is U average to first to do the integration for phi is equal to 0 to 2 pi sine theta. The expression is cos theta. You apply the limits 0 to pi. to D5. So this value comes 2. Okay. So therefore, you get U average into the integration is 2 pi. So here 2 into 2 pi, okay, 4 pi. Therefore, this is the expression for it. So what is the final expression for U average? U average is equal to P radiated by 4 pi. U average is equal to P radiated by 4 pi. Okay. So U average means radiation, average radiation used. In the previous case, we have derived average power radiated by an isotopic antenna is equal to P radiated by 4 pi r square. Here now the U average is equal to P radiated by 4 pi. Okay, so this is average radiation. It's very, very important. Okay, so the previous one, this is total or average power radiated by an isotropic antenna. Isotropic antenna. This is isotropic antenna. And this is average power intensity. This is average radiation power intensity. Power intensity. Now, another parameter we study here is gain and directivity. Gain and directivity. So, directivity is nothing but maximum. Other name of directivity is nothing but maximum gain. Okay, first we will define what is meant by gain. We will define what is meant by gain. So, gain is the ratio of 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 power density of an antenna. Power density of an antenna per test. Power density per test. TPS test in particular direction to particular direction to the average power density of isotropic antenna. Isotropic antenna. So this is the definition of the gain. Gain is the ratio of power density of an antenna test in particular direction to average power density of an isotropic antenna. What is the definition of directivity? The only change in this above expression is here the gain is the ratio of only the change is entire definition is same, but you take maximum power density. Here the only change is maximum power density. So the definition of directivity is the ratio of maximum power density of an antenna and test in particular direction to average power density of an isotropic antenna. Okay, so these are the very, very important. This is the most important parameter of an antenna. Any antenna, take any practical antenna. If you take any mobile, they'll ask what is the speed, what is the like that. The most fundamental thing is gain and directivity. Like that, the most fundamental thing is gain and directivity. Okay, so this is the only difference. The gain means general. Okay, the gain is the ratio of power density, but directivity is maximum gain. Means it is the ratio maximum power density of an antenna test in particular direction to average power density of an isotropic antenna. Okay, let us write down the expressions. Gain G of theta comma phi is equal to, the formula is PD of theta comma phi by P average. So this is the general form. Okay. So P average of an isotropic antenna. So it is PD of theta comma phi by, already you have derived, the expression for P average. With the expression for P average of an isotropic antenna, the formula is E radiated by 4 pi r square. Okay, so simply substitute here E radiated by 4 pi r square. Okay, so this is nothing but G of theta comma phi is equal to, I am bringing this r square to the top. So it is r square into PD of theta comma phi by, here what will have in the numerator, P radiated by 4 pi. So already in the previous expression, so P radiated by 4 pi is nothing but U average, and what is the value of U of theta comma U of theta comma phi? It is R square into PD of theta comma phi. So in the place of R square into PD of theta comma phi, you can simply keep it as U of theta comma phi, and P radiated by 4 pi is nothing but average. Okay, so this is the other formula for gain. This is the other formula for gain in terms of radiation intensity. So therefore, gain G of theta comma phi is equal to U of theta comma phi by U average. This is also very, very important derivation. The gain in terms of, this is gain in terms of power, this is gain in terms of radiation intensity. This is the formula for gain in terms of radiation intensity. Okay, so this is for general gain. So this is for general gain. Similarly, the same thing I will express for directivity. What is the formula for the directivity? The only difference is PD of theta comma phi. Here I want to write max. Okay, whereas in gain I am not writing max, but here I am writing PD of max by P average. P average means nothing but same PD of theta comma phi by P average means, what is the formula for P average? It is P radiated by 4 pi r square. I am bringing this r square. So directivity is equal to r square into PD of theta comma phi max by E radiated by 4 pi E radiated. So this is nothing but general formula is U of theta comma phi is r square PD of theta comma phi, but it is max means, so it is nothing but U of theta comma phi max by U average. Okay, so therefore directivity is equal to U max by U average. So this is the expression for directivity in terms of radiation intensity. In terms of radiation intensity. Okay. In terms of radiation intensity.